List all 16 possibilities of flipping 4 coins, then fill them into a probability distribution table. What a probability distribution table, and this is nothing new, it's from chapter 1, is showing all the probabilities for each one of the scenarios. X is the number of tails. What are our possibilities for the number of tails? 0 or 1 tail, right? Tail, heads, 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 for example. Or 2 tails, tails, heads, heads. Or 3 tails, 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 heads, and then you got the other ones, and then 4, right? Those are your possibilities. You can't get 5 tails because you only have 4 coins. Bless you. X is the number of tails. All right, we've got 0, 1, 2, 3, or 4. How many do we have for 0? How many ways can you get 0 tails? 1. How many ways can you get 1 tails? Should be 4. So if you got stuck, you can look. How many ways can you get 2? 6, 3, 4, and 4. Oops, 1. Muy bien. Is 1. So if I asked you what's the probability that you would get 0 tails by flipping 4 coins, what would you say? 1 out of 16. What's the probability of getting 1 tails? 4 out of 16, or 1/4, 6 out of 16, 4 out of 16. You're just taking those and turning them into probabilities. That right there is a probability distribution table. Nothing new. It's what you've seen before. It's just what are our options and what's the probability. Can I ever get 1.4 tails? Can you ever get 3.1 tails? No. So when we talk about scenario, how many numbers are there between 1 and 2? An infinite number. So there's something different between getting exact numbers, like on a die. You can either roll 1, 2, 3, 4, 5, or 6. You can't roll a 1.2 on a standard die, right? So there's got to be something that we call where we get the exact numbers versus an infinite number. And the difference is discrete versus continuous variability. Okay? I'll come back to that. I just want to show you, here's our histogram. 1, 4, 6, 4, 1. It's a probability distribution. We turn it into a histogram. What do you notice about this histogram? It's a perfect bell curve, isn't it? So if I said, what do you think on average? I said, everybody, you're going to pull out 4 coins. You're not going to, because we don't have time. But if I said, everybody pull out 4 coins, and I want you to flip them. And then we're going to find out, on average, how many tails each one of you got. And each one of you did 10 different trials and wrote it up there, and then we'd have 300 different trials. And I'd say, all right, let's find the average number of tails. What do you think the average number of tails would be? 2. Why? If it's a perfect bell curve, that we're right down the middle, right? So I agree. I think it would be 2 if we had to take a guess. However, we're taking a guess at this point. I'm going to give you an equation that finds that exactly. Okay? Let's go to discrete. In terms of definition, if you want to write something down, just wait a minute. I'll summarize it a little bit better for you. There are 2 main types of random variables, discrete and continuous. These 2 are what I was talking about. You've got discrete and continuous variability. If we can find a way to list all possible outcomes, 1, 2, 3, or 4, like flipping the 4 coins, for a random variable and assign probabilities to each one of those, then you have discrete random variable. So what you just finished with the 4 coins and flipping them, that's a discrete probability. You can't get 1.2 tails. Rolling a die is a discrete probability. You can't get 1.3 on a die, on a standard die. Those are discrete probabilities. Whereas continuous would be the Z stuff. Remember, there's an infinite number of points under the bell curve. That's all continuous that we'll be going back to. So discrete, how you want to define it, actual numbers. Some people draw a picture if you want. Some people just remember. A discrete, if I were to graph it in pre-calc or algebra 2 or something, probably pre-calc, it would be just dots. Whereas continuous would be what? I think I heard it. A line. because there's an infinite number or a continuous number of points. That's why we think of it as continuous. Couple of things, and this is nothing new. Every probability is a number between 0 and 1. On the test, we had a lot of people going through and saying the probability is 42%. No, it's not. The probability is 0.42. There's a difference between probability and percent. Number 2, the sum of the possibilities has to be 1. Remember, your whole sample space has to be 1? That's nothing new. We're just defining it now. Okay, let's move on. And you can just watch on this part, no notes. NHL goals. In 2010, there were 1,319 games played in the National Hockey League's regular season. Imagine selecting one of these games at random, and then randomly selecting one of the two teams that played in the game. Define the random variable. X is the number of goals scored by a randomly selected team in a selected game. So they've told us what X is, and you have to kind of watch for that. The table below gives a probability distribution of X. Number of goals scored in any given game, 0. Or 1 has this probability, 2 has this probability, 3 has this probability, 4 has this probability, 5 this probability. Very similar to the M&M problem that you had in that multiple choice packet, right? Same kind of deal. So, for example, the other day, if I happened to pick the Wild won 2 days ago, what was the score? Who knows? 2-1. They won 2-1. So what's the probability they would have scored 2 goals? Or what's the probability I would have picked a team, the Wild, that would have scored 2 goals? 0.228, right? About 23%. That's what that's saying. All right, A, let's do that one first. Show that the probability distribution of X is legitimate. What does that mean? It's got to all add up to 1, and just trust me, it does. Okay, but I would go through and add up all of these probabilities and make sure they add up to 1. Then we have a legitimate probability. Now, could it be 0.999? Yeah, Sam, why?
It's because that's what still equals 1.
Okay. What do we call that? Roundoff error. When we're close, I mean, these only went to 3 decimal places. If I would go out 4, I'd even be closer. You could even go over. You could have 1.01 just because of roundoff error. So don't let that throw you off. Just keep that in mind. So assume that it all adds up to 1. We have legitimacy. Boom. Take care of that. B, what is the probability that the number of goals scored by a randomly selected team in a randomly selected game is at least 6? How do you find that? Ben?
Add up the probabilities for 6, 7, 8, 9.
At least 6. 6 through 9, right? You'd add these up, and what do we get? 50, 56, 61.061. So the probability I would pick a team where they've scored 6 or more, 6, 7, 8, or 9 goals, is about a 6% chance. But the probability is 0.06 or 0.061. Any problems with that one? If you can add, you can do that one. You just have to understand what they're looking for. Okay, took care of that. B, find the average number of goals scored in a randomly selected game in 2010. In 2010, on average, how many goals were scored in any given game? You look at the average. Is it obvious? No. And that's where the equation comes in that I'm going to teach you. All right? Let me, before I go through and break down the equation, no notes on this, I just want you to watch. Okay? I want to show you where the equation comes from. Some of you will get it. Some of you go, I didn't quite follow that. Don't worry about it. All right? These are your possibilities for flipping coins. I just wrote them all out. Right? If I were to find the average, what would I do? I'd add them all up and divide by 16 of them, right? Not a big deal. Okay? Could I also do this? 1, 0, right? Plus 4 1s, plus, what do we got? 6 2s, plus 4 3s, plus 1 4 and divide that by 16, would that give me the same thing if I did it that way? Sure, no problem. What if I did this and split it up? 1 times 0 over 16 plus 4 times 1 over 16, 6 times 2. Would this be possible? I mean, does this mathematically give me the same thing? Yes. I haven't broken any rules. Could I do this? There's a 1/16th chance of getting 0. There's a 4/16th chance of getting 1. There's a 6/16th chance of getting 2, 4/16 of getting 3, and a 1/16 of getting 4. Any problems with that? Does the same thing, right? This is my first term, right? If I go back to this, there's my first term. What was its probability? 1/16. So if I go back to this, this is my first probability. This is my first term, right? Plus my second probability times the second term. Plus the third probability times the third term. Plus the fourth probability times its term. And then the fifth probability times its term. And then what do we do? Actually, we wouldn't have to because we already took that into account with the probabilities, but I would have to find the sum of them. Add them together, and that's my average. So my average is equal to the sum of whatever my term is, so we'll call it x sub I, times p sub I. Number times the probability, plus, and that's what that summation symbol means. The next one plus the next one. So all of this is me trying to prove to you this equation, because that's the equation I'm going to teach you here in just a second. Or I already have, but I'm going to show you specifically. And I just wanted to show you it's really not anything that dramatic. It's just finding averages condensed into one. You're not going to have to worry about this. This equation is, I think the next one. Yep, there it is. Mean of a discrete random variable. That's what you're looking at. And I would throw this in your notes, or it's the third equation on the page 2 of your College Board sheet. It's in your College Board sheet. It's the third equation. So if you want, flip to that. Just know where it is. I don't know if you need to write it down, because you're going to get used to it here in just a minute. Here it is. The mean of x, or what we call the expected value. You can see it both ways. Find the average. Find the mean. What is the expected value? Or what's going to be the expected profit scenario? You multiply each possible value by its probability, then add all the products. So the equation is, and here's it written out, x1 p1 plus x2 p2 plus x2 dot dot dot, meaning go till you run out of terms. Here's your generic. Mu of x is equal to e of x is equal to the summation of the term times its probability, and you go till you stop. And that's on your College Board sheet. And I believe it's this. That's on your College Board sheet. So write that down. That's your main equation for today. This one, too. Mr. Flo? Sure. Marty, to the front. Yes, sir. All right, so that's the main equation. Let's go through and use it. If I was going to, no notes on this part, just, if I was going to say, what's the average? You said 2. If I was going to find the average, I would do 0 times 1/16 plus 1 times 4/16 plus 2 times 6/16 plus 3 times 4/16 plus 4 times 1/16. It's actually very simple. It's this times this plus this times this plus this times this. You just got to remember that when you do that, it's finding the mean. Okay? So now let's go back to this example, and we'll do a roulette table. A wager players can make in roulette is called corner bet. To make this bet, a player places his chips on the intersection of 4 numbered squares on the roulette table. If one of these numbers comes up on the wheel and the player bets $1, the player gets $1 back plus $8 more. Otherwise, the casino keeps the original dollar bet. If X is the net gain from a single dollar corner bet, the possible outcomes are minus $1. In other words, you didn't win, right? So you lost $1. Or you gained $8. You got your dollar back plus $8. Those are your two chances or two options when you play roulette. Here's the probability distribution. They've already figured out because of the numbers. There must be 38 numbers, and you got 4 corners. So your probability of losing is 34 out of 38, because there's 34 in here, right? There's 34 where you can't win. 4 out of 38 where you do win. 1, 2, 3, 4, and then you win your 4 out of 38. Or that's the probability, and you win $8. So if I said, what's the expected payoff? If you played all night, for every dollar that you bet, how much can you expect to win is the question. So I do the value times its probability. That's what this is. Plus 8 times its probability. That's what this is. And comes up with a negative 0.05. What does that mean? On average, for every dollar that you bet, you're going to lose 5 cents. Who gets 5 cents? The casino gets the 5 cents. And they can play around with the probabilities all the time, and they do. Something like this, they can. It's pretty, they can't change that. They can change the game. But all the machines, they can go to the back of it, and they can change the probability. And they have to, on average, the expected average for all the machines that they have, has to have an expected payoff. They have to say the probability of people winning has to be like 7 or 9% or something like that. The only reason I knew that is because it was on the news about 5 years ago. Every once in a while, the government goes in and checks casinos, make sure they're not ripping off people. And they found Mystic was not, I believe it was Mystic, was not meeting up to their standards. The expected payoff was not the percentage that they should have been. So they had to go through and change the machines. Now that's the expected payoff. Not every machine has to be that way. They can set some machines to be 3%, and then they can put a couple that might be 14% chance. Where would they put those machines? Not in the back. In the front. Because what happens is everybody sees, oh, they're winning as they're walking in the door. They see them winning, and they go, wait a minute, I want to play. And then they go somewhere else and play. Don't go to the back. That's where they're going to have lower probabilities. It's the front that might have higher probabilities because they want people to see that win. Or if it's right next to a bingo hall, those right there, they might have the high winners. If people are playing bingo, watching these people win, right? They just suckered you in. So they can play around with it, but the expected payoff has to be 7 to 9% or something like that in terms of people winning. Okay, so let's go back to the hockey then. Okay? I want to know the average number of goals scored in a randomly selected game. I can't tell you right now. Take out your calculators. I'm going to show you how to do this in your calculator. It'll make things a lot easier in terms of finding your expected. Right now, don't do it right now, okay? But this is the rule, okay? You would take this 0, multiply it by 0.061, plus 1 times 0.154, plus 2 times 0.228, plus 3 times 0.229, all the way down. You'd have to type that all in, hit enter, and that would be your expected count. Let's find out how to do it. If you only have 2 or 3, easy. If you have a bunch of them, then we should do it on our calculator. And if you're going to do it and you have to show work, you set up a couple of them, and then just do plus ... and you're done. Okay, you don't have to type them all in if I say show you work. All right, you ready? So stat edit list 1. Put in 0 through 9 for list 1. Clear out whatever your list 1 is in your list 2. 0 through 9 is your list 1. So here's L1. L2 will be our probability. I'll read them to you. It'll be easier that way. So 0 through 9 in list 1. Anybody not done? All right. Go to Stat, Edit, List 2, clear it out. I'll read you the numbers. Type these in. 0.061, 0.154, 0.228, 0.229, 0.173, 0.094, 0.041, 0.015, 0.004, and 0.001. Now these should match up. Does order matter?
Yes.
Yeah, you should have these numbers matching up. That will make a difference. Okay? I've already got it in there. Stat, edit. We got them in there. List 1, list 2. We got them good to go. Okay? How do we find the probability? How do you find the expected payoff of X? List 1 times list 2, right? This times this. And that'll give me everything multiplied. This multiplied, and this multiplied, and this multiplied, and this multiplied. Right away. So if I go to my calculator, go to list 3, clear it out, and then do L1 times L2. Hit enter, and you got your numbers. Now what you have, these numbers right here, correct? If I do this, okay, these numbers right here represent this times this. This 0.14 is these two multiplied, etc., etc. So what do I need to find my value? I need to add them up, right? Find the summation. Two different ways you can do summation. One, second stat, so list, math, sum is number 5. I put it in the wrong spot. Stat, try that again. Second stat, so list, math, sum of list 3, please, 2.851. Now, I'm guessing a lot of you might forget that a month from now. So you can always go to stat, calculate one variable stats for list 3. We've done that. This right here, the sum of x, is your 2.851. It is the sum of that column. Most people will probably remember that. So what's our expected number of goals? On average, how many goals are scored in the NHL on any given night? 2.851 is the average number of goals. And you leave it as 2.851 because they're asking on average how many. You don't try to round it. You actually leave it as the average would be 2.851 goals. Rachel.
Isn't that per team? Or is that per game?
X is the number of goals scored by a randomly selected team. So on average, yes, per team. So if I pick the Wild or I pick the Canucks,
So
or
would it be goals scored in a game if it's just goals scored in a game, not a team?
that's true. Sorry, goals scored in a game for a particular team.
Okay.
Yes.
Would
Thank
you know
you.
how to do a goal scored in a game from this or no?
Well, you have two teams.
So would you just add them?
It'd be they scored 2.85 and the second team scored.
So far.
So you'd square it.
Okay. Square it?
Well, 2.85 and 2.8. Wild and
Would
their
you add
opponent.
them?
No, because you're asking for an and. They score 2.85 on average,
Oh, okay.
and they score. So I would say you probably square them.
Okay.
Good question. Let's see. Did we get everything? Yeah. Questions? So I showed you how to do it on the calculator. And here's your shortcut that way. And then your equation, your general equation, which is this. Don't forget about this. And that is on your College Core sheet. So today was about finding the expected value. And the expected value and the definition of what a discrete random variable is, because we're eventually going to get into a what if it's continuous.